Right now, trillions of molecules released from the forests of Appalachia are rising invisibly into the sky. They aren't pollution, but a massive exhalation from oaks and poplars, drifting eastward and shaping the air you breathe. This invisible forest breath doesn't just create the Blue Ridge's famous haze. Researchers have found it alters clouds and even shields the East Coast from warming. But why are the trees releasing these gases? And what else are they changing right now above your head? Every summer, the forests stretching along the Appalachian Mountains become one of the planet's most powerful sources of invisible gases. The numbers are staggering. Globally, trees release about 500 million tons of isoprene each year, a single compound among a family of volatile organic chemicals. In the United States, forests emit between 15 and 20 million metric tons of these gases annually. That is on par with the total output from every car, truck, and factory combined. The Appalachian region stands out as a global hotspot, thanks to its dense stands of oaks, poplars, and other broadleaf trees, and the long, sunlit days of its humid summers. Here, the forest canopy acts less like a passive shield and more like a living factory. As sunlight pours through the leaves, vast amounts of isoprene and related compounds are released into the air above the ridges and valleys. The sheer scale is hard to imagine. Millions of tons of gases rising invisibly each year from the mountains, drifting eastward on the wind. These emissions are not a quirk or a side effect. They are a fundamental part of the region's natural cycle. The Appalachian forests in the heart of the eastern U.S. are quietly shaping the chemistry of the atmosphere on an industrial scale. Inside the dense Appalachian canopy, leaves are at work in ways that go far beyond photosynthesis. As the midday sun heats the forest, each leaf begins to release a steady stream of volatile chemicals, chief among them isoprene. This is not a random leak. It is a carefully tuned biological response triggered by rising temperatures and intense sunlight. When the heat builds, the leaf's delicate membranes are at risk of damage. Isoprene acts as a shield, stabilizing these membranes and allowing the plant to keep functioning even during the hottest hours. Some scientists compare this process to sweating in humans, but here it is a chemical sweat, an invisible plume of gas rising from every branch and leaf. Oaks are the champions of this strategy, along with poplars and willows. They top the list of natural isoprene emitters. On a hot summer day, the air just above an Appalachian forest can contain between 5 and 30 parts per billion of these gases, levels that are undetectable to our senses but easily measured by scientific instruments. This protective emission is not a sign of stress or sickness. It is a sign of resilience, a way for the forest to buffer itself against the extremes of its own environment. Each tree, each leaf, is engaged in a quiet, ongoing negotiation with the climate, using chemistry as a tool for survival. The result is a living system that breathes out vast quantities of reactive gases, setting the stage for the transformations that follow high above the treetops. High above the Appalachian canopy, a chemical transformation is underway. As isoprene and other volatile gases drift upward from the leaves, they meet a turbulent mix of ozone and hydroxyl radicals in the summer air. The encounter is anything but gentle, and within minutes to hours, these invisible gases are oxidized, broken apart, and rebuilt into new molecules that have little in common with their origins. Many of these oxidation products are so low in volatility that they condense out of the gas phase, clustering together to form nano-sized particles known as secondary organic aerosols. These particles are minute, less than a micron across, far smaller than the width of a human hair. Suspended in the air, they become the raw material of the region's famous haze. But the story of the Blue Ridges is not just about the presence of haze. It's about the way these particles interact with light. The physics here is subtle but profound. When sunlight strikes a cloud of fine particles, the shorter blue wavelengths are scattered more efficiently than the reds and yellows. This phenomenon, known as Rayleigh scattering, is what gives the sky its color. In the Appalachian Mountains, the same principle is at work, but on a backdrop of mountain ridges and forested valleys. The result is a soft, bluish veil that hangs over the landscape, turning distant hills into a series of fading, ethereal silhouettes. Decades of atmospheric research have shown that this blue haze is not a simple byproduct of mist or smoke. It is a living chemical signature, evidence of the forest's ongoing dialogue with the air. Each summer, as millions of tons of biogenic gases rise from the leaves, they are transformed into particles that not only shape the region's iconic vistas, but also play a critical role in the optical character of the atmosphere. The Appalachian Range, through this chemistry, has become a visible artist, tinting the horizon blue with every breath of their collective forest. Particles born from Appalachian forest gases don't more than tint the air blue. They become architects of the sky itself. Once volatile compounds like isoprene and terpenes are transformed into fine secondary organic aerosols, their journey continues upward. Suspended in the atmosphere, these nano-sized particles serve as the seeds around which clouds begin to grow. Cloud droplets cannot form from pure water vapor alone. They need a nucleus, a tiny speck, to gather around. The organic haze drifting above the ridges supplies exactly that. On a global scale, natural vegetation produces an estimated 88 teragrams of carbon each year in the form of secondary organic aerosol. This is not a minor contribution. In fact, the mass of organic particles generated from tree emissions dwarfs that produced directly by human activity. Over the southeastern United States and the Appalachian corridor, these forest-made particles mix with traces of industrial sulfate and other pollutants, further enhancing their ability to draw in water and initiate cloud formation. As the haze thickens and particles grow, a significant share reaches the right size and chemistry to become cloud condensation nuclei. When humid air rises over the mountains, water vapor condenses on these particles, giving birth to new clouds. The result is a landscape where forests are not only exhaling chemicals, but also helping manufacture the very clouds that shade and water the land below. Every summer, the invisible breath of the Appalachians is woven into the region's weather, linking the chemistry of leaves with the architecture of the sky. For much of the 20th century, the southeastern United States stood out as an anomaly on the world's climate maps. While global temperatures climbed, this region cooled by as much as 1 degree Celsius, especially in summer. The explanation lies in the sky above, the air thick with microscopic particles. Aerosols, both from industrial pollution and from the forests themselves, acted as a shield. These particles reflected sunlight back into space and brightened clouds, reducing the amount of solar energy reaching the ground. The Appalachian forests, continually releasing isoprene and other volatile compounds, supplied a steady stream of organic particles that joined with industrial sulfates overhead. Together, they created a dense, cooling veil, one that muted the effects of global warming across the region. This natural and human-made partnership in the atmosphere helped carve out what scientists call the warming hole, a climate shield that set the Southeast apart from the rest of the warming planet. Winds rising over the Appalachian Mountains carry more than just the memory of forests. They sweep up a living plume of molecules that travels east, sometimes for hundreds of miles. Synoptic weather patterns draw these fine particles and gases out of the mountains, across the Piedmont, and toward the Atlantic. Along the way, the chemistry of the plume keeps evolving. Sunlight and urban pollutants transform the original forest breath, but the signature remains. From Georgia to Maine, the air is quietly shaped by what began in the leaves. Even in coastal cities, every inhale contains traces of Appalachian forests, molecules that started their journey beneath a green canopy, now mingling with the breath of millions. The forest's invisible exhalation becomes part of the daily atmosphere, linking distant mountain ridges to the lungs of people far downwind. Right now, every breath in the eastern United States carries the unseen work of forests, shaping clouds, cooling cities, and engineering the climate we depend on. As global warming accelerates, these natural emissions remind us the future of our atmosphere is still being negotiated, leaf by leaf.